Hi. This week you were introduced to the four classical experiments: the Millikan oil drop experiment, the Thomson cathode ray experiment, the Rutherford Goldfoil experiment, and the experiment that we now know as mass spectrometry. And from these four experiments, we learned about the constituents of the atom. There are the electrons, abbreviated E minus. Their charge is -1. There are the protons, abbreviated P plus. Their charge is +1. And finally, there are the neutrons, abbreviated N, which have no charge. The protons and the neutrons are inside the nucleus, the small object from which the alpha particles bounced back in the Rutherford Goldfoil experiment, and the electrons are outside the nucleus. And we learned the values, the actual values of the charges and the masses. The charge of the electron is a negative charge, and it is equal to -1.602 times 10 to the -19 coulombs. That's a unit of charge, the coulomb. The proton is the same charge of the electron, but with a plus sign. We also learned about the masses. The mass of the electron is equal to 1, and I'll give you more significant figures, over 1,823 grams per mole. And the mass of the proton and the mass of the neutron is around equal to 1 gram per mole. The masses can vary slightly. The mass of the neutron is also around 1 gram per mole. And the unit, grams per mole, 1 gram per mole is referred to as 1 AMU. And AMU stands for atomic mass unit. Okay, so this is what we learned in the last time. What I'd like to now do is give you a picture about what atoms look like based on the classical experiments. And so the original picture based on these classical experiments is called the planetary model. And the planetary model has now been updated, but we'll learn about that later. The planetary model is still useful, though. It is a starting point, and it's called the planetary model. There's the nucleus, that's the small object, and around the nucleus orbits the electrons. The electrons orbit around the nucleus, and they are moving then up. We can think of first in a circle. Very much the same way as here's the sun, and going in an orbit around the sun is the Earth. So that's why it's called the planetary model. I would also like to tell you about the nomenclature that's used describing the protons and neutrons. I am going to tell you about isotopes. And we're going to look at the isotopes of neon. Last time, remember that we learned that neon, all neon, it's the 10th atom in the periodic table. When it's neutral, it has 10 electrons and 10 protons. All neons have that. But in the mass spectrometry experiment, the neon plus is divided into two beams. It turns out that some of the neons have 10 neutrons, and there are others, they have 10 electrons and 10 protons, and they have 12 neutrons. And the nomenclature that we use to describe these two situations is that we look at the mass. The electrons are so light we don't even need to count them. But there's 1 AMU, 1 gram per mole for the protons, 1 gram per mole for the neutrons. There's 20 protons and neutrons here. So that's 20 AMU in total. And this neon is called 20 neon, where we put the 20 in the upper left-hand corner. So that's one type. This type has 10 protons and 12 neutrons. That's 22 AMU. 10 plus 12 is 22, and this is called 22 neon. That's all I wanted to say for today, and then we'll have some problems tomorrow to review all the various things that you've learned, and see you tomorrow.